I'd like to present a couple of concepts or points that'll help you finish lab number 1 for natural disasters class. One point is the nature, the character of this particular axis on the graph of velocity versus depth that you'll be using. These are what we call relative depths, where the bottom of the stream is 100% or 1.0 of the total depth, and the surface is 0 times the total depth, or 0. So these are relative. These aren't in meters or anything. These are actually in fractions or percentages. So the 0.2 is actually the point that is 20% of the way from the surface to the bottom of the stream. So if you're looking for the midpoint from the top to the bottom, that would be 50% of the way from the top to the bottom. It would be right here. And conversely, if you want to know how deep 0.6d is, you would multiply 0.6 times the total depth of the stream. So if you need to find 0.6 times the depth, and the stream happens to be 12.5 meters deep, you'll multiply 0.6 times 12.5 meters. The reason that the axis is represented like this is that it's independent of the actual depth of the stream. So the same graph and the same relationship can hold whether the stream is 1 meter deep, 100 meters deep, 12.5 meters deep. It's all relative or proportional. So if you want to multiply 0.6 or the 6/10ths rule times a specific depth, you'd multiply 0.6 times 12.5 meters. Another point that I need to make is this particular slide, which won't actually show up in lecture for a little while yet, and the reason for that is that we don't have lab on week 2, so that kind of confused the schedule because it's Labor Day. The important point that you'll need to finish the lab exercise is this idea that discharge or flow rate is equal to the velocity in a stream, how fast the water is moving, and that's the average velocity, not the surface velocity. Remember, the average velocity is at 0.6 times the depth. If you multiply that velocity times the cross-sectional area, that will give a flow rate. And that is how it's a geometric relationship, and that's how we actually, in reality, measure the flow rate or discharge in a stream by measuring the depth or a variety of depths and finding the average, finding the width, measuring the velocity, and multiplying together. And this will be exposed in this part of the laboratory, where we're given a hypothetical stream of 25 feet wide and 6 feet deep, and that means then that the area, the cross-sectional area, is 150 square feet, and we're given the velocity, so there's no computation needed there, and then applying the fact that discharge or flow rate is equal to area times velocity, we see that the answer to the first problem is 300 cubic feet per second.